Hello all, this is Anita. Welcome to the machine learning video lecture series. In this video, we will understand the k nearest neighbor algorithm in detail. So, in this video, we will understand the introduction to the KNN. Then we will see why do we need the KNN algorithm. Then we will see the KNN algorithm working. Then how to calculate the distance between the 2 points, how to choose the k value, and then we will see the advantages and the disadvantages of the KNN. So let's get started. So the first we will understand the introduction to the KNN. So here the KNN stands for the k nearest neighbor algorithm, and it is one of the simplest supervised algorithm used in the machine learning for the classification and the regression task. So KNN algorithm is assume the similarity between the new cases or the data and the available cases and put the new cases into the category that is most similar to the available category. So the KNN algorithm store all the available data and classifies the new data point based on the similarity. So here the KNN algorithm at the training phase just store the data set, and when it grow new data, then it classifies that data into the category that is much similar to the new data. So the KNN is a non-parametric algorithm, which means that it does not make any assumptions on the underlying data. And it is also called as lazy learner algorithm because it does not learn from the training set immediately. Instead of that, it stored the data set, and at the time of classification, it perform an action on that data set. So here we will see the KNN with the help of example. So suppose there is a data set that contains the information regarding the cats and dog, and there is a new data point, and you need to check if that sample data point is a cat or dog. So to do this, we need to list out the different features of the cat and dog, and based on that we will train our algorithm, and when new data point or the new input comes here to the model, so we can easily determine if it's a cat or dog. The new data point feature indicate that this animal is a cat animal. So here our KNN is based on the feature similarity. So we can perform this classification task using the KNN classifier. So this image here you can see the train with this KNN algorithm, and it shows that the predicted outcome is a black cat. Now you can see on the right hand side I have taken the another example, and as here we have a data set having the two classes as the class A and the class B, and we need to find out this particular point is belonging to the which class. So at that time you need to find out the nearest neighbor. So here you can see we have found the nearest neighbor to particular star. So here these 3 points are nearest to this star, and based on their feature we are moving this star into the particular category of the class. Now we will see why do we need a KNN algorithm. So here suppose there are the two categories of the classes, so like class A and class B, and we have a new data point. So this rectangle is a new data point here. This we can say it is like a 1 point, and so this data point we want to find out this data point lie in which of these categories. To solve this type of problem we need a KNN algorithm. So this is what the before KNN, and for solving this problem we will be using the KNN algorithm. So with the help of the KNN we can easily identify the category or a class of a particular data set. So here we are finding the nearest neighbor, and based on the majority of the classes we are categorizing this particular point into the class B. So this is how the KNN algorithm works. Now we will see the working of the KNN algorithm. So here first we will see some theoretical steps of the KNN algorithm, and then we will understand with the help of example. So the first point is we choose a number of k neighbors. Then we will calculate the Euclidean distance of the k number of neighbors. Then we will find the k nearest neighbor as per the calculated Euclidean distance. Then we will find among these k neighbors, count the number of data point in each of the category. Then assign that new data point to that category for which the number of neighbors is maximum, and at the end our model is ready. So these are some theoretical steps of the KNN algorithm. Now we will see with the help of the example. So here, our second step is we will after selecting the k nearest neighbor, we are calculating the Euclidean distance of that k number of neighbors. So first we will understand how to calculate that distance between the 2 points. So here in KNN algorithm, this there are various methods for calculating this distance, of which most commonly known methods are the Euclidean distance. Then the second one is the Manhattan distance and the Hamming distance. So these three methods are there. So we will see one by one. So the first method is the Euclidean distance method. So here Euclidean distance is calculated as the square root of the sum of square difference between the new point and the existing point. So this is the formula of calculating the Euclidean distance. The second one is a Manhattan distance. So here this is the distance between the real vector using sum of their absolute difference. So here you can see this is the formula of the Manhattan distance. Now the third one is the Hamming distance. So it is used for the categorical variable, and if the value of x and the value of y are the same, the distance d will be equal to the 0, otherwise the distance d equal to 1. So this is the formula of the calculating the Hamming distance. Now we will see the working of the KNN with the help of example. So here you can see, suppose we have a new data point and we need to find out, or we need to put it in a required category or in a class, like in a class A or in a class B. So that we need to find out. So consider this is how the data set is distributed. So firstly, we will choose the number of neighbors. So we will choose here that k is equal to 3. So that is our that k value. So that is our first point. So after selecting the k value, what we will do next? We will calculate the Euclidean distance between the data point. So that Euclidean distance between the two data points that we will calculate. So here you can see, and that like how to calculate that Euclidean distance, that we have already studied in the geometry. So it can be calculated with the help of the formula. So you can see here, this is the formula. So suppose this is my first point and this is my second point. So here how we are calculating square root of like x2 minus x1 plus y2 minus y1 whole square. So this is how we are calculating. After calculating the Euclidean distance, we got the nearest neighbor. So by selecting the closest point, we will got the nearest neighbor. So the number of points to be considered is determined by the value of that k. So here, as we have taken the k equal to 3, so these 3 points we have considered as the neighbor of this new data point. And as we can see here, the two nearest neighbor are from the class B and one is from the class A. So here you can see from class A, red point is from class A and two blue points are from the class B. Now, as our KNN tends to favor the majority classes, hence our new data points is must belonging to the that class B, because from the class B we have taken the two majority class points. So that's why it is belonging to the class B. So this is how our KNN algorithm works. Now for working KNN, we have chosen the k value. So how to choose that k factor? So in earlier example, we have taken that k is equal to 3. So how to choose that k value? So here that KNN algorithm is based on the feature similarity. So selecting that right value is a process. It is called as a parameter tuning, and which is important to achieve the higher accuracy. So actually there is not a definitive way to determine the best value of the k, but it depends on the what type of problem you are solving or as well as your business scenarios. But the most preferred value of the k is a 5, so that is a preferable point. So selecting a k value of 1 or 2 can be the noisy. So here you can see for a very low value of k, that is like k equal to 1 and 2, so it can be very noisy and it may lead to the outliers in the model, or your model is overfitting the training data, and which leads to the high error rate on the validation set. And the high value of the k are good, but it may find some difficulties, and sometimes your model perform poorly on both the training and the validation sets. So that is why we need to properly choose the value of k. Now we will understand the advantages of the KNN algorithm. So the first advantage is no training period. So here KNN modeling does not include the training period, as our data itself is a model and which will be a reference for the future predictions, and because of this it is very time efficient in terms of the improvising for a random modeling on the available data. So here as there is no training period, so thus the new data can be added at any time, so since it won't affect the model. The second one is the easy implementation. So the KNN is very easy to implement, as the only thing is to calculate the distance between the different point on the basis of the data of the different feature, and this distance can be easily calculated using the distance formula, such as that Euclidean distance or that Manhattan distance. The last one is the versatility. So the KNN can be used for both the classification and the regression task, and it makes the KNN is applicable to the wide range of the problem. Now we will understand disadvantages of the KNN algorithm. So the first one is does not work well with the large data set. So as it calculating the distance between the each data instances, so it would be very difficult and it would be very costly. The next one is does not work well with the high dimensionality, and the last one is the feature scaling. So here the data in all the dimensions should be scaled or should be normalized and standardized properly, and it need for appropriate k value. So here the choice of the k is significantly impact the performance of that KNN. So the small k value can lead to the overfitting, while the large k value can causes the underfitting. So selecting that optimal k value often required experimentation and the domain knowledge, and sensitive to the outliers and the missing data. So here you can see we will understand how it is sensitive to the outliers or the missing data. So let us see, suppose this is how our data is distributed, and this green point is my new data point, and I want to classify this particular point is belonging to the which category. Either it goes to the white category or that yellow category. So here you can see, and suppose our k value is equal to 3. So that time we will categorizing this new data point is belonging to this particular. So here we have taken the k value is 5. So you can see with the help of this we are saying our green data point is belonging to the that white point, because they are nearest to that. So this is what the outlier effect. So this KNN is a sensitive to the outliers. Now take a pause here and tell me, is KNN suitable for the imbalanced data set? And after done, resume the video. So here KNN is less suitable for the imbalanced data set, because KNN tends to favor the majority class when making the predictions. So that's why it is less suitable for the imbalanced data set. So here we need a proper handling technique like oversampling or adjusting the class weights. So these are the references that I have used. Thank you.